Hello, I'm Byron Katz with Coveros. Let's talk for a moment about one of the Git commands, Bisect, and how it can make you a more capable developer. Git Bisect follows the binary search algorithm to pinpoint the commit where a bug was added. Let's say a bug was noticed in your application and you need to correct it. You'll need to find the exact code that contains the bug. There are a variety of ways to do so. You could step through code with a debugger. You could read the code looking for likely culprits. You might add logging statements and scan the logs while using the application. Sometimes it helps to ask the people involved in its development. One last idea is that you could have a test that determines if the bug exists. When running it on the current version of the code, it would find the bug. But as you stepped back through commits, it would stop finding the bug. At that point, you know which commit added the error. If the commit was a small one, it makes finding and correcting the bug much easier. Git Bisect takes this concept one step further. Instead of simply going back one commit at a time, it takes a shortcut by following the binary search algorithm. Let's take a few seconds to explain that. I'm going to demonstrate binary search by using the example of a guessing game. I'm thinking of a number from 1 to 10. You guess which number I am thinking of in the least number of tries. Each time I'll reply higher, lower, or that you correctly guessed the number. The smartest way to do this is to start at the midpoint of the range, then, based on the answer of higher or lower, choose midpoints of smaller and smaller ranges until you finally terminate at the correct value. Let's show that. 5, higher. 8, higher. 9, higher. 10, yes. Let's reset and try again. 5, lower. 3, higher. 4, yes. You can easily search online for more detail on the binary search algorithm. Now let's leverage our knowledge of binary search to understand Git Bisect. Similar to the demonstration of binary search we saw earlier, we are examining an ordered list of values, but these values are commits, bounded on one side by code where the bug definitely exists, we mark it bad, and on the other side where it doesn't, which we mark good. Git Bisect chooses commits for you, and you determine if the bug is still there or not. Usually, by building the code at that commit and testing for the bug in some way. Whichever it is, if the bug is there or not, you indicate to Git Bisect, which then chooses another commit to test. Eventually, just like we saw with the demonstration of the binary search algorithm, you arrive at the commit where the bug was created. Then it's just a matter of reviewing what changed in that commit. Hopefully, it's a small commit. A caveat. If it's difficult or impossible to test for the bug quickly and accurately, Git Bisect may not be the right tool for this job. Let's get a bit more practical and demonstrate this functionality. Here I have an example application that is outputting a defect. Let's see how we would find the defect by using Git Bisect. First, we start up Git Bisect mode. Since we can see the defect is happening, we can go ahead and mark this commit as bad. Let's pick an earlier commit where we know this defect wasn't happening. If we test at that point, we see that the defect isn't manifesting. We'll mark that one as good. Now, Git chooses the halfway point commit for us, just like the binary search from earlier, and we see if the bug exists there. It still exists there, so we indicate that to Git, and it chooses a new commit that's halfway between that point and the commit marked good. This time, we see that the defect doesn't exist. We tell that to Git, and it chooses a new commit that is halfway between that point and the old midpoint. As we proceed, Git keeps choosing new commits in whichever direction, towards good or bad. Eventually, we arrive at the commit where the bug was added. Now you understand how Git Bisect works and how to use it. I'll briefly discuss a few extra features that Git Bisect provides for added versatility. You can tell the system to skip certain commits that you know don't add the defect. You can create a script that runs a test against your codebase and have it run the Bisect tool automatically. As we saw before, Git Bisect will choose certain commits using the binary search algorithm, but with this feature, it will run a given test each time to determine whether the bug was found. This makes the tool completely automated. You can ask Git Bisect to visualize what the range looks like. I've included some links to greater detail in the description. Thanks for watching. If you enjoyed this video, please mark that you liked it.